Okay, I'm going to try and do a quick explanation of a new diagramming system and coding methodology I'm developing. And the idea here is to take a complex coding project and break it into small units that can each be individually written and tested in isolation, and then be able to recompose it back into the full integrated system and run it. Before I address this kind of complicated graph, I want to show you a simpler version of a diagram representing the same thing. So this is kind of a toy model for a knowledge graph system that takes some unstructured text, like a PDF file, and some ontology, which is the entities and relations you're interested in it. And it's going to use an LM to extract that information into entities and relationships, and you can insert it into a primary knowledge graph. And from there, you could ask things like, what are the most common entities and relationships? You could retrieve information from the subgraph based on a query, and then you can even take that information, summarize it with an LLM, generate some summary text, and then feed that back into the LLM extraction to create a new knowledge graph from that and insert it into your primary knowledge graph. It represents branching logics, so you can do two things from here, and it also represents loops. One of the main differences between this graph and the graph I'm going to show you is we're going to take each one of these individual nodes and we're going to turn it into three nodes. So what we're going to do is we're going to attach an input port and an output port to each one of these nodes. And each of these input ports and output ports are going to have specific schemas. So this formal ontology schema will be an output port that binds to the input port of this LM extraction. And they bind because they both have the same schema. Same thing here. This is just going to be a raw text schema, and it's going to bind to another input port here, which accepts raw text schemas. The other thing that's going to be different, I'll get to in a second here, but I want to show you what this looks like. So if you look here, this is that same LLM extraction, and now it has an input port that is that ontology of a certain scheme that it takes as input, and then it's also got the original text down below that it's taking as input. The other main thing that's different here is the processes in this diagram never create new data. What they do is they create commands which will invoke methods on data classes. And so what I mean by that is we have a knowledge graph data class. So instead of, again, this being just a knowledge graph, what we have is we've attached input and output ports to it. And this knowledge graph has a method which inserts data into it. So over here, what's happening is we put the ontology and the entity and relationship extraction into, we generate a command here to invoke this method and insert the extracted entities and relationships into the knowledge graph. In addition to that, we've got representation of routers, so we can do the branching logics. We can also represent loops, and the way we're going to do this is you code up this whole system, and then you have basically an execution config file that's going to declare all of the routing logic and specific execution pathways you want it to take. The other thing here is this diagramming tool incorporates instance management. So in this graph, for example, if you wanted to have multiple different knowledge graphs and multiple different analyses of the entity and relationship distribution for each one, this will automatically handle it. So the idea here is to develop an auto coding system where you start out by declaring what data you're going to provide, what data you want it to output, and the functionality that you want it to provide. And an LLM is going to code up this whole diagram into a visual mermaid chart. And then the next portion of the program is taking this fully specified diagram of what the code needs to do, and it codes and implements and tests each one in isolation and then recomposes it into the whole system. So this diagram is a tool to go from the code description to a diagram, and from the diagram to the code. And then later on, it can also be used as a visual coding tool where you could actually write the code here. You could also turn your existing code into a diagram. So it's a coding tool. It's eventually potentially a visual coding methodology and a way to transfer code into a visualization. So I think this is going to be a powerful system to leverage large language models in code, because the biggest problem right now is that they're good for really simple systems when it can keep the whole system and its interactions and downstream dependencies in its attention space. But for complex systems, it always fails, and it doesn't have the individual units communicate properly. The value of this system is that the integration between all of the different parts is programmatically handled. And I think this is really going to allow large language models to build some really cool projects fairly autonomously.